Hey everybody, and welcome back to McArdle Math Academy. In this video we will be looking at an application of combinations, and in this case we'll be looking at poker hands. So before we start, I want to just look at a standard deck of cards just to remind everyone what that consists of. There are 4 suits: clubs, spades, hearts, diamonds. There are 13 different kinds of cards. So when I say kind, what I mean is it's either an ace, a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, or king. And of each kind, of course, you have the 4 cards from all the 4 suits. And that's a total of 52. When you play poker, you are dealt 5 cards. And again, because all those cards are in your hand, the order does not matter. And for that reason, we will be looking at combinations instead of permutations. Let's kick things off by looking at the total number of possible poker hands. So we're dealing 5 cards from a total of 52. Therefore, we're choosing 5 cards. Order doesn't matter, so we use combinations. And there are 52 options for me to choose from. Okay, so when you do this out, you'll get the following with our formula, which I'll write on the left here. And you can see that the answer is 2,598,960. Again, I'm applying the formula for combinations, which I won't go over here, and we're simplifying factorials, which again I won't go over here. We're going to focus on the poker. Let's ramp it up and make it a little more difficult here, and let's look at how many poker hands there are that have 4 of a kind. Now, to have 4 of a kind in your hand, that means you have 4 cards which are of the same kind, so they're either all aces, all 2s, all 3s, etc. And then you have 1 additional card. So we're going to break this up when we form these hands. We're going to break it up into 2 pieces. The first piece will involve selecting which kind you want to fill out the first 4 cards, and then the second task will involve picking your 5th card. Okay, now since this is 2 distinct tasks, we know that by the multiplication principle, we can have options for the first task, and we multiply that by options for the second task. So the first task, we want to choose our kind. Well, how many ways can we do this? We're going to be choosing it, since its order doesn't matter. Of the 13 different kinds, we're picking one of those kinds. So if we pick 2s, 2s are going to fill in the first 4 slots, etc. Now for the blue piece here, choosing that 5th card, we will be picking 1 card from the remaining 48 cards. Now, why are there only 48 cards? Well, we already took 4 from before. We took 4 to fill these slots. So that means there's only 48 cards left in the deck, and we're choosing 1 of those. So by the multiplication principle, all we have to do is solve for these 2 combinations and multiply them together. And we'll get 624 total hands that have 4 of a kind. Now let's look at how many poker hands have 2 jacks and 3 tens. Again, this is going to be essentially 2 tasks when we're looking for the total number of options. We have to consider options for the 2 jacks. That's going to fill in the first 2 slots. And then options for the 3 tens. Okay, and again, by the multiplication principle, if we have options for that first task, we can multiply them by the total number of options for the second task. Let's look at the purple part first. We're going to choose 2 jacks. That means we're choosing 2 jacks from a total of 4. There's only 4 jacks in the deck. We're choosing 2 of them. Similarly, for the tens, we're going to choose 3 tens from the total of 4 tens available in the deck. So we're going to do out these combinations, and I'll put the answer right here. And the answer is 6 times 4, which is 24. Let's do one more example, guys. Suppose that you were asked how many poker hands have full houses. Now, a full house is a 5-card hand that has 3 of one kind, so maybe 3 aces, 3 jacks, 3 tens, and 2 of another kind, so 2 2s, 2 3s, etc. So again, here's our 5 cards. To find the total number of possible hands that we have, we're going to break this into 2 tasks. First, you choose 3 cards of one kind, and then you choose 2 cards of another kind. Now, this is the most complicated example we've done, but it still follows the same principle. It's going to be number of options for the purple piece times number of options for the blue piece, or the blue task. All right, let's look at the purple task first. So if we want to choose 3 of one kind, well, our first job is to figure out which kind we're actually wanting to choose from. So there's 13 different kinds. So your first task is to choose your kind From 13, we choose 1. So you might say to me, well, I want my first 3 cards to be aces. Well, great. So we're going to pick that first. This is the number of different kinds that we have in the deck. We're choosing one of the 13 possible kinds. Now, once we have the kind figured out, so you might say, I'm going to choose aces. Well, you have a few different ways that you can pick 3 aces from the available 4. And the number of ways we can do that is the combinations of picking 3 from a set of the 4 of the kind that you picked. Okay, so again, all of this multiplication here wraps into choosing 3 of one kind. You're essentially choosing the kind first, right here, and then choosing the 3 cards of the 4 possible cards from that particular kind. And we do the same thing in blue. So we're going to choose another kind, but now there's only 12 kinds left because we used one of them. And then for that kind, we're going to pick 2 cards from the available 4 cards available in that kind. All right, so this entire product becomes our answer. Our 2 tasks were split up into these 2 distinct tasks, which were each kind of complicated because you had to pick the kind first before picking the cards. And I'm going to do the math out here and get your answer. It turns out that we get a total of 3,744. Now, this same strategy can be applied to a number of different examples involving poker. I suggest trying some on your own, and I'll see you guys next time.